Some mysteries are easier to solve than others. Where did you put your glasses? How have so many soccer balls ended up on the roof of the elementary school? Those kinds of things don't stay mysteries for long. But how Vikings navigated the seas and what took down ancient civilizations might take longer to puzzle out. The cool thing is, archaeologists have solved these mysteries, and a lot of other tricky ones too. Here's just a sample of the coolest mysteries archaeologists have figured out, starting with the strange mystery of Stonehenge.
Look, you don't have to know a lot about ancient history and prehistoric monuments to have heard of Stonehenge. The story of this incredible structure goes back more than 5,000 years, and while it was certainly important to the people who built it, those architects would have no way of knowing that their creation would become world famous. These days, Stonehenge is featured everywhere, from popular movies to your friends' vacation photos. But if there's one thing that everyone seems to know about Stonehenge, it's that there is a lot that nobody seems to know about Stonehenge. The monument is surrounded by famously puzzling questions like who built it, what was it used for, who is buried beneath it, and especially how did ancient people manage to move and erect these huge stones? Over the years, lots of explanations have been proposed, including lost technologies, outright magic, of course you've got aliens. But while speculation is fun and all, Stonehenge doesn't need any help from myths and legends to be cool. After all, just because you understand something doesn't make it any less fascinating, and there is a lot about Stonehenge we understand. Archaeologists have been intensely studying this structure for more than a century, and while many mysteries still remain, modern science has taught us quite a lot. For centuries, visitors to Salisbury Plain in Wiltshire, England, have marveled at Stonehenge and tried to guess at the identity of its builders. One of the earliest written suggestions came from Geoffrey of Monmouth, a bishop famous for his fanciful writings on British history. In the 1100s, he claimed that the monument was built by Merlin. Yes, the wizard Merlin of the Arthurian legend. The story goes that Merlin used magic to construct Stonehenge as a monument for fallen soldiers, using huge rocks that were originally carried out of Africa by giants. And for a while, this was actually a pretty popular story. Later scholars got more realistic, though, and proposed a list of non-fictional suspects, including the Romans and the Mycenaeans from Greece. And while artifacts found at Stonehenge indicate that some of those cultures did use or visit the monument in its later years, recent evidence has ruled them out as its builders. A lot of that evidence has come from radiocarbon dating. This method is one of the most useful tools that archaeologists have because it mostly just requires some radioactive carbon. In nature, carbon atoms come in a few different forms, or isotopes, which have different numbers of neutrons. Some of these isotopes, like a key one called carbon-14, are radioactive, so they break down over time at really predictable rates. By figuring out how much radioactive carbon has decayed in a material, scientists can calculate how long ago the material formed. And that means they can place a date on all sorts of organic substances, including ones found at Stonehenge. Radiocarbon dating of human remains and artifacts has revealed that the monument's history actually goes back to around 3000 BCE, which is definitely too old to have been built by the Romans or Mycenaeans, or Merlin for that matter. Unfortunately, whatever group made Stonehenge didn't leave behind much evidence about who they were, so their identity remains a mystery. And the story is complicated even more by the fact that, like many ancient landmarks, Stonehenge wasn't built in a day, or even a century. Archaeologists have identified multiple phases of construction at the site over a period of about 1,500 years, possibly by different groups of people. The earliest construction happened around 5,000 years ago, and it involved the digging of the circular ditch that still surrounds the monument. This formation is very similar to a type of earthwork called a henge. We know this partly from carbon dating pieces of tools that were left behind, but we've also found cremated human remains from this period hiding in pits within the henge. It's possible that some of the early stones were also put up around this time, but based on other evidence, it's most likely that the famous giant standing stones didn't arrive for another 500 years. So even if there isn't enough evidence to say who exactly did the heavy lifting here, archaeology has been able to help us understand when it happened, which has ruled out some suspects. Merlin. Science has also been able to help us figure out how Stonehenge was built. And one thing is for sure, getting all of these rocks into place was no easy task. There are two major categories of stone, also called megaliths at Stonehenge. There are the enormous sarsens, typically weighing around 22 metric tons each, while the smaller bluestones are a modest 2 to 5 metric tons. Today there are around 3 dozen stones at the site, arranged in 2 outer circles and 2 inner horseshoes. But based on holes dug into the ground, there likely used to be more. From what we can tell, workers first dug holes for the rocks to sit in, and then hauled them upright, probably with the help of ropes, A-frames, and lots of people. The standing stones were then capped with horizontal beams to form what architects call lintels, like the beam over the top of a doorway. These were probably lifted up there on wooden platforms that were dismantled after construction, but these lintels weren't just plopped down. Holes, tabs, and joints were carved into the rocks so that the architects could insert tab A into slot B and fit them all together like a very heavy piece of IKEA furniture. Admittedly, this is some pretty advanced engineering for that time period, but unlike what a lot of internet forums and YouTube videos say, it is not impossible. The builders might have lived a few thousand years before cranes and power tools, but they still had all that good old-fashioned human ingenuity and human muscle, which we tend to overlook. Also, never underestimate the power of a good ramp and pulley system. Archaeologists think major work on Stonehenge continued until around 1500 BCE, and in that time, more earthwork features were dug and the bluestones were rearranged multiple times. But who built the structure and how aren't actually the biggest questions scientists and historians have asked. Instead, the real mystery is how the stones got there. See, the big sarsens are made of sandstone, and the bluestones are variously formed from rhyolite, dolerite, and other types of rocks, but none of them match the geology of the nearby area. Thankfully, no matter how far a stone has traveled, it still has the same geologic age and composition as the formation it came from. So after analyzing the mineral makeup of the stones at Stonehenge, as well as determining their age with other forms of radiometric dating, geologists have been able to go hunting for outcrops that match its features, and we think we've found some answers. Although there's still plenty of debate, many scientists believe the sarsens came from a region called Marlborough Downs, around 32 kilometers from Stonehenge, and the bluestones most likely came from the Preseli Hills of Wales, more than 200 kilometers away. A 2015 study from the journal Antiquity even identified a site that not only matches the geology of the bluestones, but also shows evidence of quarrying during the right time period. The researchers have suggested this might actually be a site where Stonehenge rocks were extracted, which is pretty amazing. Of course, that still doesn't explain how people moved these rocks. It seems like an overwhelming task, to the point where it's been proposed that the rocks weren't moved by humans at all. For once, though, I'm not talking about aliens. I'm talking about glaciers. It's been suggested multiple times that these huge stones may have been glacial drop stones, carried by advancing glaciers and deposited when the ice receded. But modern archaeologists tend not to agree with this. For one thing, they point out that there's a lack of good evidence for glacial activity on the Salisbury Plain. We don't see any major piles of glacier-carried rocks, and certainly no deposits of the type of stones used to build Stonehenge. And for another, they argue you don't need glaciers to explain the movement of these megaliths. Again, human ingenuity is enough. For example, some researchers think the rocks may have traveled over water. Ancient peoples could have loaded them onto boats and carted them along rivers and coastlines. Some people have even traced out specific waterways that could have taken the bluestones from the Preseli Hills in Wales all the way to Stonehenge. On the other hand, the stones could also have moved over land. In 2016, a group of students from University College London conducted an experiment to test just how hard it would be to move a megalith. Inspired by technologies from ancient Japan, they constructed a large wooden sleigh laid on top of a path of wooden logs. They put roughly 1 metric ton of stone on the sleigh and pulled it across London's Gordon Square. With only 10 people pulling, they were able to move the rock up to 3.5 kilometers per hour. So maybe Stonehenge architects used a similar technique. Or, like other scientists have pointed out, maybe they just rounded up a bunch of people and carried the rocks. All in all, it's hard to say which of these ideas, if any, is the closest to the truth, because no one has found any direct evidence of a transport route. It has, after all, been an awful long time. But there's good reason to suspect that people were at least capable of moving these megaliths without any help from magic or space tractor beams. Historians are still investigating why they might have gone through so much trouble, but either way, with all of the hard work that went into building it, it's pretty clear that Stonehenge was important. It may have served a number of purposes, but scientists know for sure that it was a long-used burial ground. The cremated remains of more than 60 people have been extracted from beneath the monument, and it's estimated that there may have been more than 150 burials at the site over its centuries of use. For a long time, we didn't know who these people were, but recent research has begun to unravel that mystery too. New excavations at Stonehenge in 2008 opened up the doors for more modern scientific analysis on these remains, including a technique called stable isotope analysis. Unlike radiocarbon dating, this method looks at isotopes that haven't decayed much over time, and instead of being used to determine age, it can be used to examine the chemical makeup of remains. Kinda like the stones themselves, the bodies at Stonehenge hold the chemical signatures of the environments they lived in, picked up from the water they drank and the locally grown food that they ate. That can tell scientists where they likely lived. A 2018 study in Scientific Reports found that some of the bodies had isotopic signatures that matched the local environment, so these were probably people who lived nearby. But others had signatures that pointed to more distant regions, like Devon or Wales. Since these signatures are also affected by the type of wood used for the cremation process, the researchers were also able to find evidence that some of the dead were cremated elsewhere and brought to Stonehenge for burial. It's not yet exactly clear who these people were, but it seems people from near and far were buried here, maybe because their relatives were, or because this site was used by a culture that was often on the move. More digging and more research will hopefully tell. Regardless, whoever it was that built, used, and buried their dead at Stonehenge, we do know that they weren't alone. Whether because of the environment or other factors, the Salisbury Plain is one of the richest archaeological regions in the world. There are hundreds of other burial sites and ancient remains, and researchers have used all kinds of cool methods to investigate them, including ground-penetrating radar and lasers. So there may still be a lot of mystery surrounding Stonehenge, but those questions aren't unanswerable. And as we keep researching and introducing newer technologies, more science and more knowledge is yet to come.
It's hard to narrow down exactly who built Stonehenge, how they did it, and why. Maybe it was a grave marker and served as some form of communication about where to find the dead. After all, ancient communication is pretty hard to decipher, and it was even harder before archaeologists cracked the code in the Rosetta Stone. Here's past me with the info on how archaeologists uncovered that mystery. Okay, so first, a little background. You're probably familiar with hieroglyphs. These are the symbols you've seen written on ancient Egyptian artifacts or in documentaries like The Mummy, the documentary. Hieroglyphs are the original writing system of the ancient Egyptians. The name comes from a Greek word meaning sacred carvings. The first hieroglyphs appeared around 3000 BCE, or roughly 5,000 years ago, and they stayed in use for roughly 3,500 years. In Egypt's long history, versions of this script were used for everything from decorating temples to writing grocery lists. But by the 4th century CE, hieroglyphs were mostly used in a religious setting, which unfortunately set them up for their downfall. Egypt was conquered and made a part of the Roman Empire in 30 BCE, and while the Roman Empire was historically fairly tolerant of other faiths, in 3rd century BCE, Christianity became the official religion of the empire. This new Christian empire ordered the destruction of pagan temples and banned the use of hieroglyphs. The last known hieroglyphs were made in 394 CE. Soon thereafter, people lost the ability to read them entirely. Luckily for us, the desert preserves things remarkably well, so for centuries, people could see that ancient Egyptians had left behind this treasure trove of writing on ruins and papyruses. Papyri? Anyway, even though they found it all over the place, no one knew what any of it said. Scholars over the centuries tried to decipher the mysterious script. In the 9th century, an alchemist living in what is now Iraq may have successfully deciphered a few hieroglyphics. Later, a 17th century Jesuit priest claimed to have cracked the code, though this work was later discredited. The big problem all these translators ran into was that they had nothing to compare hieroglyphs to. No one even spoke the language of the ancient Egyptians anymore, and nobody had any two documents in different scripts that they even thought might say the same thing. What the world needed was a key to break the code. That chance came in 1799 with the discovery of the Rosetta Stone. In 1798, Napoleon invaded Egypt, which was then ruled by the Ottoman Empire. The story goes that a French officer named Bouchard was dismantling a fort near modern-day Rashid in 1799 when one of his men came across a stone carved with hieroglyphs. Bouchard knew they'd found something special. See, the bottom third of the Rosetta Stone is written entirely in Greek, and scholars at the time loved reading in Greek. Bouchard and other researchers of the day figured that the other two languages carved into the stone might be copies of the same message that was written in Greek. If scholars could figure out how to pair hieroglyphs with the Greek words, they might be able to crack the code on this ancient writing system. News of the stone echoed throughout Europe. This was the best chance in centuries for scholars to learn what ancient Egypt had to say in its own words. By reading Greek, scholars knew that the stone was a decree issued by ancient Egyptian priests to celebrate the accomplishments of a young king called Ptolemy V. All they had to do was pair this message with the hieroglyphs and voila! Some people claimed it would take just 2 weeks to crack the code. It did not take 2 weeks to crack the code. All in all, it took 20 years before any real progress was made. A lot of researchers had their fingers in the pie. Many studied texts from Arabic and medieval scholars who tried their hand at decoding hieroglyphics. In the end, 2 major discoveries are responsible for the Rosetta Stone's decoding. The first came in 1814 when a British polymath called Thomas Young made a crucial realization. Most scholars at the time assumed that hieroglyphs weren't phonetic. Instead, they thought each image represented a discrete word or idea, sort of like Japanese kanji. The Rosetta Stone had these pockets of outlined hieroglyphs in the stone, which we now call cartouches. Young realized that these pill-shaped sections of the text corresponded with areas where the Greek text referred to King Ptolemy. This led him to argue that the symbols in the cartouches corresponded to the sounds in Ptolemy's name. That was strike one for the symbol-only theory of hieroglyphs. Then a French scholar named Jean-François Champollion took it even further. Champollion realized that there were simply too many hieroglyphs on the stone for each one to represent their own idea. So instead, he approached it as a phonetic language rather than a pictographic one. Champollion translated Greek words into Coptic, a dead language that was once used by Egyptians before they picked up Arabic. From there, he was able to sound out the hieroglyphs, pairing each image with its own sound. In a classic Archimedes move, Champollion reportedly jumped up and yelled, "I've got it!" when he made the discovery. He published his work on this in 1822. And while this was a major discovery, it wasn't 100% accurate. We now know that hieroglyphs are a mix of symbolic and phonetics, and this system was so complex that we still have trouble reading them. But this moment marked the first time in 1400 years that anyone at all could begin to read this ancient language. Now that we've established how the Rosetta Stone was translated, let's talk about what the heck it even says. Because the very first question on anyone's mind was, why does this ancient Egyptian artifact have Greek writing on it? This is tied to the history of the stone. The Rosetta Stone originally was part of a stela, a kind of square column with a rounded top. It was made in 196 BCE as part of a decree to celebrate the accomplishments of Ptolemy V, who at the time the decree was written was a whole 13 years old. The reason why Greek is included in the Rosetta Stone is that it was the administrative language used in ancient Egypt during the Ptolemaic dynasty. Alexander the Great invaded Egypt in 332 BCE. After he died, one of his generals took over Egypt and became pharaoh. So Ptolemy V is the descendant of that Greek-speaking general. The priests of Memphis are basically trying to hype this young king in the eyes of the Egyptian public. The actual message of the decree celebrates Ptolemy's military victories and his decision to lower taxes. The decree also states that copies of this message are to be carved in stone in all temples across Egypt. And indeed, we found around 28 other stone copies of this message so far. To reach the most people, the decree is composed in Egypt's 3 languages. You've got sacred hieroglyphs to speak to the gods on top, and Greek, the administrative language, on the bottom. So what about this middle part? This is a language called Demotic. It also has a long history that we simply do not have time to get into, but basically this would have been the everyday language of Egyptians during the Ptolemaic period. You see, Egypt was around for so long that their spoken language outpaced the writing system by a lot. By the time Alexander the Great was invading Egypt, hieroglyphs didn't really match up with how people actually spoke in their day-to-day. Like if you ever go and look at how Old English was written, hieroglyphs probably looked like that to Egyptians living in the Ptolemaic time. Priests still wrote in hieroglyphs because it was sacred, but everyone else needed a writing system for the everyday stuff, writing a contract or a list or what have you. That was Demotic. Unfortunately, Demotic went out of style too because translating it was a whole thing. So the priests who wrote this message on the stone probably spoke to each other in a language that corresponded to Demotic, wrote in Greek, and had that message translated into hieroglyphs. This decision to spread what essentially amounts to Ptolemy propaganda written 2,000 years ago now means that modern Egyptologists can read hieroglyphs for themselves. And translating these hieroglyphs was more than just a fun exercise. Unlocking the secret to what the ancient Egyptians were writing about way back then helped us learn a lot of basic info we'd been missing. Stuff that's as basic as how old Egypt really is. In 1824, Champollion translated hieroglyphics from the 3,000-year-old temple wall of Ramses II. Champollion compared this list to a papyrus called the Turin Canon, a document that listed kings and queens, including those not typically counted in the official line of succession. Scholars at the time thought that Egypt was founded somewhere in the ballpark of classical Greece or Rome, so 500 BCE-ish, but the temple and the papyrus combined revealed that Egypt's pharaohs stretched back way, way further, all the way to 3100 BCE. Since then, hieroglyphs have been a key component in helping us decode the ancient world of the Egyptians. Nearly 100 years after they'd found the Turin Canon, the archaeologist Howard Carter used hieroglyphs to identify that the newly discovered site he'd been working on was the tomb of King Tutankhamun. Hieroglyphs and hieratic script, which is just curvy hieroglyphs on papyrus, has taught us about Egypt's dynasties and collapses and kings and, well, everything. The Rosetta Stone isn't a source of much active research these days, but its gift of decoding ancient Egyptian life is still an important part of Egyptology today. People often think that archaeologists have worked out everything there is to know about ancient Egypt, but that's not true. This culture lasted so long and had so many dynasties that each new site is an opportunity to learn something new about these ancient people. Like, we don't know a lot about the time that Egypt was ruled by people from modern-day Sudan during Intermediate Period 3. And whatever we'll learn about that time will only be possible thanks to understanding hieroglyphs. But while there's not a ton of ongoing research on the Rosetta Stone, it's a pretty hot topic for a totally different reason. At least 3 invading armies are intimately tied to the history of the stone, and that kind of violence leaves an impact. Today, the Rosetta Stone is one of the most visited artifacts in the British Museum, but not everybody wants it there. The British Museum came to own the stone after a combined Ottoman-Anglo force defeated the French army in Egypt in 1801. Part of the treaty required France to give Britain all the antiquities they'd found during their invasion. And today, the British Museum seems to be a big fan of the philosophy of finders keepers, meaning that they have no plans to give it back. Various figures within Egyptian academic circles, as well as the people in Egypt, would very much like the Rosetta Stone to be returned to its homeland. However, opponents of returning the stone point out that Egypt has its own copies of the decree found at other sites. But obviously, none of these other copies of the decree are the iconic Rosetta Stone, so advocates for repatriation aren't going to give up anytime soon. The Rosetta Stone was the answer to a puzzle that had befuddled scholars for hundreds of years. It was the perfect tailor-made solution to an otherwise impossible translational mystery. So much so that the phrase Rosetta Stone is a synonym for any discovery that suddenly broadens our understanding of a bunch of things all at once. So now you know the history and legacy of this iconic, controversial, and remarkable piece of ancient history. Part of why it took archaeologists 2 decades to decipher the Rosetta Stone was the lost skill of reading certain languages, which makes you wonder what other skills we've lost over time, like navigating the open water, using crystals. How Vikings made it back from their treacherous voyages was a mystery to archaeologists until they learned about the cool rocks Stefan is about to describe.
Iceland spar might seem mystical, but it's made of a fairly common mineral called calcite, otherwise known as calcium carbonate. Now, our Rocksbox subscribers will know all about calcium carbonate from our video on aragonite. Aragonite and calcite are both polymorphs of calcium carbonate, meaning they have the same chemical formula but with slightly different crystal structures. In general, calcite is the more stable of the two, and it's the most common form you'll find on the Earth's surface. And you can find calcite pretty much anywhere. It's the major component of limestone rocks, which makes up about 1/4 of all the sedimentary rocks on Earth. Metamorphic rocks cooked from these calcite-rich limestones make calcite-rich marble, and you can find it deposited in just about any other kind of rock, when calcium carbonate-enriched fluids form veins through the crevices. Calcite itself has a trigonal structure, which means its simplest crystal shape is a rhombohedron, basically just a skewed cube. But there are a ton of different shapes and colors that the crystals can take, depending on impurities present and the space and time the crystals had to grow. They can be clear, white, yellow, brown, or a whole rainbow of other colors. And they can grow as prisms, spikes, pyramids, globules, or as smooth or fuzzy coatings like on stalactites and cave walls. Iceland spar is just one of these crystal forms. It's super pure, making it clear and colorless, and it grows very slowly in plenty of space, letting the crystals take their natural rhombohedral form. As well as its common name, which honors the place where it was originally found, Iceland spar is also known as optical calcite because of what it does to light as it passes through. Take a look through one of these crystals and you'll see what I mean. You get 2 slightly offset images of whatever's on the other side. But don't worry, you haven't had too much Brennivin. That's Iceland's national liquor, and it tastes great if you love licorice and alcohol. This double vision effect is caused by birefringence in the crystal. And to understand birefringence, we need to talk about the polarization of light. Light essentially consists of electromagnetic waves, which oscillate in a direction that's perpendicular to their direction of travel, like waves traveling along a string. The string goes up and down, and you can see the peaks traveling forward. But with natural light, the oscillations don't just go up and down. They also move left and right, and top right, bottom left, and so on. They can basically oscillate in any direction that's perpendicular to the one they're traveling in. And because there's no favored direction, we say that these natural light sources are unpolarized. Now, when light travels through transparent materials like glass or water, it gets bent or refracted. That means when it exits the other side, the image is shifted from where you'd expect it to be if the light had continued in a straight line. The amount it bends depends on the refractive index of that particular material, which is the ratio between how fast light moves through a vacuum and through the new material that's now bending it. But birefringent materials like Iceland spar do things a little bit differently. Birefringent materials have different refractive indices for light of different polarization angles. So these components of the incoming light wave end up being bent differently. The result is 2 separate light rays traveling through the material polarized perpendicular to one another. We can't see the polarization directly, but we can see the separation of the 2 light paths because they produce an offset double image. And Iceland spar has this polarizing birefringence because of an asymmetry in its crystal structure. You can get birefringence in other materials too, like quartz, ruby, and weirdly cotton, but none of these are quite so striking as in this pure optical calcite. In fact, the whole concept of birefringence was first documented way back in 1669, and they used crystals of Iceland spar to study it. But there's a good chance that the crystal's optical trickery was known about far earlier than the 17th century, and might just have been used to help ancient Viking seafarers find their way. The Vikings were a society originally from Scandinavia who dominated the open seas of the North Atlantic between 800 and 1050 CE. They were known for raiding and settling many of the islands and coastlines of the area, including Iceland, England, Greenland, Svalbard, and Newfoundland. But exactly how they accomplished this is a bit of a mystery. Navigating the open ocean when you can't see the shoreline requires you to be able to keep track of what direction you're headed in. And these days we use magnetic compasses to do that. But 1,000 years ago, people didn't fully understand the magnetic effect, and usable compasses didn't arrive in Europe until the 14th century, which is way after the end of the Viking era. So since they couldn't use magnets, scientists think that the Vikings would have used the sun to keep them on course. Naturally, this is a bit trickier than relying on the magnetic North Pole because the sun moves in the sky during the day and throughout the year. But it seems they had a few workarounds. For instance, archaeologists found a wooden disc-shaped device in Greenland called the Unartok disc, which they think was a kind of sundial. This disc could have helped seafarers keep track of their direction or latitude based on the shadows cast by the sun. And that's great and all, but there's another problem with relying on the sun to navigate. You can't always see it. At the high latitudes of Iceland and Greenland, there are many months where the sun is just skirting the horizon or even stays below it all day long. Plus, cloudy conditions would make it hard to know exactly where the sun was, even if it was above the horizon. So how did these people solve this problem? Well, we think something they called sunstones were part of the answer. An Icelandic legend written in the 13th century about a Norwegian chieftain mentions using a so-called sunstone to locate the sun in overcast, snowy weather. Unfortunately, the saga gives no details about what exactly the stone was or how it worked, but researchers think that it let them see polarization in the sky. Like we said, light coming from the sun becomes polarized when it passes through the Earth's atmosphere. Gas particles that are smaller than the wavelength of light can scatter the incoming light in what's known as Rayleigh scattering. Different wavelengths are scattered by different amounts, which is what makes the sky appear blue. But Rayleigh scattering in the atmosphere also polarizes the light coming from the sun, leading to a pattern of polarization in the sky. Light that is close to the line of the sun's rays hasn't been scattered much, so it's not polarized. But at further angles from the sun, the scattering is greater. So the light is strongly polarized. Effectively, that creates a ring of polarization that's centered on the sun and hits its peak about 90 degrees away from it. We can't see this polarization with our naked eyes, but there are some animals that can. Certain insects, like bees and spiders, have special eyes called ocelli, which have light sensors that only allow certain polarizations of light through. This means that certain areas of the sky would appear darker, allowing these insects to intuitively know the position of the sun even when it's hidden behind trees or clouds. So if the Vikings found a way to visualize the polarization of the sky in the same way, then they too could intuit the position of the sun and use it for their navigation. And that's where the Iceland spar comes in. Because of these crystals' birefringence, you can use them to figure out the changing degree of polarization and even the angle of polarization in the sky. You might be able to see this effect yourself if your rocks box includes a really clear sample, or you have some other really clear sample to experiment with. Here's how. To start with, you need to create a double image on the crystal itself. You can do this by making a mark or sticking a piece of tape on one face, or by blocking off the faces so that only a thin beam of light comes through. Looking through the crystal should then show you a double image. Oh, and by the way, if the sun is visible while you're trying this, don't look at it, because, I don't want you to hurt yourself. Then if you hold the crystal up to the sky and move it side to side, you'll see that one of the images gets much darker than the other one. The direction you're facing when it's darkest is about 90 degrees away from the direction of the sun, because of that Rayleigh scattering ring we talked about. And if you're having trouble seeing it, you can try it at a time of day when there aren't any buildings blocking out the sun, or from a location with good sightlines of the horizon. So if you find all the directions where there's the maximum contrast between the two images, you'll map out that ring. And in the center of that ring is where you'll find the sun. And we have evidence that this works outside of your backyard too. A study in 2013 showed how people using a crystal of Iceland spar could estimate the position of the sun to just 1 degree of accuracy. That's about the thickness of your pinky finger held at arm's length. That said, some researchers argue we're overthinking this whole navigation by polarization business, because you can usually see well enough where the sun is based on how the clouds or the horizon is illuminated. But a study in 2011 showed that while this certainly gives you a rough idea, in practice people are pretty bad at estimating the sun's position this way, and the results are really inconsistent, especially at twilight. Still, other researchers thought that the difference in the refracted images you see in the crystal might be hard to make out in cloudy conditions. But a study in 2014 showed that while the visuals aren't as well defined on cloudy days as they are in full sun, the technique could still be used to locate the sun, even at twilight when the sun is below the horizon. So if it could work, what are the chances that Viking navigators actually did use these crystals as their wayfinding sunstones? The theory is there then, but the physical evidence was still lacking. If these sunstones were so indispensable, you'd think we'd find them left and right at Viking sites. The thing is, calcite is a pretty fragile crystal, and it's possible that hundreds of years of wear and tear would render the crystals unrecognizable, which might explain why they're so hard to come by. These things are a 3 on the Mohs hardness scale, meaning you can scratch it with a copper penny. And not only that, but calcium carbonate is soluble in weak acids. But in 2002, divers exploring a shipwreck in the English Channel did find a white opaque rhombohedral crystal near some other navigational tools. It became known as the Alderney crystal, and it was from the late 16th century, so a bit after the end of the Viking era. Although this crystal was calcite, its opacity wouldn't have made it much good for navigation. That said, we don't know if it was this opaque when the ship went down, or if the seawater damaged it between then and now. Research in 2013 showed how exposure to seawater could alter the transparent crystal enough to make it opaque, so it may have been crystal clear when the ship went down. So perhaps it's not surprising that the Vikings' Iceland spar crystals haven't survived the last 1,000 years. But the Alderney crystal does at least give archaeologists an idea of what to look for in Viking settlements and shipwrecks.
Now that we know how to safely travel over water to our destination, we can get to Easter Island, where yet another ancient mystery takes place. Easter Island is home to the famous giant heads carved into stone. You might have heard that the island ran out of resources to support the people living there. But here's what really happened on those farms. Rapa Nui is a tiny, isolated island in the Pacific Ocean, 3,800 kilometers west of South America. The first human inhabitants arrived from other Polynesian islands around the year 1200 CE. At first, the island was covered in palm trees, but then the humans got to work cutting some of them down, and the rats that had hitched a boat ride feasted on the saplings and nuts. Within a couple hundred years, almost all the trees were gone. Without the trees' protection, strong winds eroded the soil and dried it out. Rainfall was unpredictable, and when it did rain, the soil drained quickly rather than retaining moisture. The island has very little fresh water, so irrigation wasn't really an option. And to cap it all off, the soil was relatively poor in nutrients. In fact, you might have heard this as a cautionary tale about ecological destruction. According to this debunked and frankly insulting narrative, the population of Rapa Nui grew dramatically during the period of deforestation and then crashed because they were too greedy to use the island's resources responsibly. And sure, the deck was kinda stacked against them, but human ingenuity came to the rescue. The archaeological evidence actually shows that the Rapa Nui people were able to sustain a small and stable population, probably around 3,000 to 4,000 people, for a long period of time. They did this thanks in part to a set of agricultural techniques called rock gardening. Rock gardening is pretty much what it sounds like, putting rocks in gardens or agricultural fields. Rapa Nui is volcanic and has many outcroppings of basalt, so people would break off rocks from these outcroppings and carry them to their gardens about 65 meters away. When life gives you rocks, make rock aid? They constructed 3 types of rock gardens. For veneer gardening, they placed a layer of fist-sized rocks directly on the ground. Lithic mulching involved adding broken rocks to the soil from the surface down to about 20 centimeters. The last type was boulder gardens, where they simply placed large stones on the ground. In some gardens, as much as 80% of the surface was covered by rocks. Now, this still doesn't sound terribly useful. If the fields are full of rocks, where are all the vegetables? But trust me, this actually works. Rock gardening offers a bunch of benefits that enabled the Rapa Nui to grow tubers like sweet potatoes. Remember how dry the soil was? Well, rock gardening decreases evaporation, allows more precipitation to filter into the soil, and decreases water runoff. Studies done elsewhere suggest that over a 2-year period, soil with rock mulching can store 30 to 40% more water than the bare soil does. The rocks took care of the runaway wind, too.
By creating a rough landscape, rock gardening slows down the wind and reduces soil erosion by at least 4 times compared to non-mulched land. Rock gardening also puts the kibosh on pesky weeds, and as the weather gradually breaks off tiny fragments of basalt, the soil gains some nutrients like calcium. All this leads to more seeds successfully sprouting, heftier plants with deeper roots, and higher crop yields. We don't know how big the benefit was for sweet potatoes on Rapa Nui, but in later experiments, the yield of maize in a rock-mulched field was up to 4 times the yield in a non-mulched field. The Rapa Nui weren't the only civilization to realize that humble rocks could work wonders for food production. We don't know how widespread rock gardens used to be, since Western archaeologists have often overlooked them or misinterpreted their purpose, but evidence of historical rock gardening has been found all over the world. For example, the Hohokam people in present-day southern Arizona built thousands of rock mounds to cultivate agave during droughts. And more than 2,000 years ago, the Nabatean people in the Negev desert in the Middle East grew olives, pomegranates, and apples on rock terraces. Now, it's not like you can just throw some rocks in your garden and expect a bountiful harvest year after year. Rock gardening decreases the organic content of soil by up to 10% after just 1 year, and it's not exactly easy to mix organic matter back into the soil that's covered with rocks. As a result, the practice could deplete some soil nutrients over a few decades. A saying among Chinese farmers using rock gardening in the early 20th century was, "The father works hard, the son gets rich, but the grandson becomes poor." Today, vegetable growers commonly use plastic mulch to achieve many of the benefits offered by rock gardening, like retaining soil moisture and inhibiting weed growth. But plastic mulch has to be replaced frequently, and the microplastics that end up in the soil and our food aren't healthy for us or the planet. So could rock gardening be a low-tech solution, especially in light of our changing climate? After all, it's not just a historical practice. Some Rapa Nui people still have rock gardens today. As the planet's fever keeps getting worse, rock gardening could help protect crops against extremely hot days. That's because the turbulent airflow over the rough surface acts like a soil thermostat, cooling it in the day and warming it at night. But rock gardening is hard to do at a large scale. Just imagine the labor involved in transporting 6,000 softball-sized rocks for a garden the size of a basketball court, let alone the 28 million you'd need for the average-sized farm in the US. Still, rock gardening could be useful for small-scale farming in arid regions. It can help farmers be more resilient to droughts, which are becoming more common and more severe in many parts of the world due to climate change. In the US Southwest, for instance, researchers have proposed that going back to growing agave in rock gardens could be a good way to adapt to the changing climate. Rock gardening is just one of many indigenous agricultural practices that Western agronomists have long overlooked. And it's amazing how simple this is, right? Can't grow stuff? Try adding rocks.
The garden rocks are cool, but I'm always going to think the giant heads are the most impressive thing on Easter Island. I mean, come on, it would probably take a satellite view to fully appreciate them. And that wouldn't even be the only archaeological mystery observed from space, because researchers are using satellites to map tombs.
5 hours of off-road driving from the city of Kassala in eastern Sudan lies a collection of ancient tombs. Researchers have written about them for years, but they aren't as well studied as other archaeological sites because of their remote location and their number. There are a ton of tombs, enough that examining them one by one would take too much time. So archaeologists resorted to a less traditional way of studying them. They used a statistical method designed to study something a little different: the stars. There are 2 main types of tombs in this area. There are tumuli, which are simple raised structures made of earth and stone, and there are kubas, square shrines or tombs constructed with flat slabs of metamorphic rock. These tombs come from 2 different periods. Kubas are from the medieval Islamic period in the area, which ended sometime in the 15th century, while the tumulis date back even further to prehistoric Africa. This overlap of cultures makes these tombs of particular interest to archaeologists, because these tombs can contain information about the cultural landscape and history of the region. And we still don't know how many there are, but we know that they number in the thousands. There are so many that counting and cataloging them all by hand would require multiple trips out to this remote region and a lot of work. In the past, archaeologists might not have had much choice but to plan an expedition and look at each tomb by hand. But nowadays, modern archaeologists can use technology to make the task a lot easier. And in the case of the tombs in Sudan, archaeologists realized that they could use a statistical tool to model how the tombs were arranged, which had previously been developed to model stars. Satellites have been used in archaeology before to get an eagle-eye view of remote regions where exploration could be challenging. And the site in Sudan, well, it would be a perfect candidate for satellite work. But while satellites can take a nice aerial picture of the site, they aren't, like, smart or anything. They can't determine which tombs are related to each other. And that's an important aspect for researchers studying funerary practices and traditions. So for that, a different tool needed to be used. The Neumann-Scott cluster process. Scientists developed it to understand how stars and galaxies in the sky are grouped together. It's a type of cluster analysis, which is a way to tell how random points can be grouped together and how they relate. So for example, if you're doing market research, a cluster analysis might tell you that customers share something, like an age or a zip code or some other demographic, just by looking at each individual's behavior. You could find that one cluster of customers are mostly millennials, and you might find another that's mostly Gen Z. But when you turn cluster analysis to astronomy instead of economics, these types of statistical analyses can look at stars as points on a map and tell you which stars are likely to be grouped together. The thing is, normal cluster analyses look at each point as an individual, independent from all other points. And that isn't exactly how stars work. Stars and galaxies are affected by gravitational attraction, which means that they tend to be associated more with certain stars than others, and might even group around a central point. So to properly track the movement of stars, you need a system that considers points that might be connected to each other. And that is where the Neumann-Scott cluster process comes in. Instead of just looking at individual points, this process detects things that are called offspring points, which tend to cluster around parent points. That means it looks for points that branch out from each other. For example, regular cluster analysis might help you find clusters of trees when looking at a rainforest, but the Neumann-Scott process could help you find regularly spaced parent trees with their offspring trees clustered around them. It's the fact that this process takes relationships into account that makes it useful for archaeology. Satellite images of the Kassala site show that the arrangement of the tombs depends on the topography of the area, which makes sense, because tombs were more likely to be built in foothills or on top of ridges than in slopes. That's because it's harder to build on a slope than it is to build on something flat. But when the researchers applied the clustering process to these images, they found 6 main clusters of kubas, and not all of them could be explained by topography. Using the Neumann-Scott cluster process, the researchers found that there seemed to be some kind of social gravitational attraction. Just like with the stars, kubas were clustered around central points, possibly connected to tribes and families. These kubas also tended to cluster around the much older tumuli for reasons that are yet unknown. By comparing the arrangement of the tombs with historical sources, researchers were able to find that these kubas were probably tribal or family cemeteries of the Beja people who lived in the Kassala region. One interesting thing, the kubas in Kassala are located 60 kilometers south of the site previously thought to be the southernmost occurrence of Islamic Beja funerary monuments, which means that scholars underestimated the number of kubas in the region and their location. The Beja people have settled in the region since time immemorial, and ancient written records support them being in the region before 2,000 years ago. So the kubas and tumuli might be more culturally connected than what researchers previously thought. Of course, the authors could have found all of this out the old-fashioned way by exploring the region and looking at each cluster separately, but this would have taken much more time and much more money. But now, researchers can not only use statistics to unlock the secrets of the universe, they can also apply those same techniques to unlocking the secrets of our history.
While we're talking about tombs, it's high time we dove into all of the mysterious skeletons that archaeologists have discovered. And one of the weirdest ones has got to be the skeleton who turned out to be 8 different people. Neba can tell us how archaeologists figured that out.
Now, when those original archaeologists discovered this body, they based its age not on the skeleton, but on an artifact that had been buried with it, a bone pin. Bone pins were used as hairpins during Roman times, so it was a reasonable hypothesis that the skeleton it accompanied would date to the same time period. But the team had ignored multiple red flags. First off, the skeleton was on its side with its limbs tucked up, kind of in a fetal position. But when the Romans buried their dead, they laid them flat on their back, legs outstretched, arms at their side. This curled up position was reminiscent of a much older burial practice in that area. A second red flag was that just looking at the bones, you can see that some of them don't quite match up. Some looked much younger than others, and some of the vertebrae didn't quite fit together. So nearly 50 years later, a 2019 study finally brought in good old radiocarbon dating to get a clearer picture. Radiocarbon dating is is a way to figure out how long ago something died by looking at a particular type of carbon, carbon-14. Like all living things, we're constantly absorbing carbon into our bodies as we go about our daily lives, and the vast majority of it is in a stable form called carbon-12. However, we also absorb a teeny tiny bit of the much rarer and radioactive carbon-14. Every 5,730 years, half of the carbon-14 atoms decay and break apart. That decay keeps happening after we're dead, but being dead, we're no longer replenishing our supply. So by comparing the amount of carbon-14 to the amount of carbon-12, you can figure out how long something has been dead. In the case of this Gallo-Roman cemetery, carbon dating confirmed that the 76 cremated graves were indeed from Roman times, but it also revealed many of that single skeleton's bones were thousands of years too old to be Roman. So a 2024 study took an even closer look with more radiocarbon dating and DNA analysis, and the team realized just how confusing a puzzle they had on their hands. But before we get into that, we've got to keep the lights on. So first, an ad. The radiocarbon dates reveal that the bone pin was indeed from Gallo-Roman times, but all the skeleton bits they dated came from the late Neolithic period. And not just one point in the late Neolithic, they ranged anywhere from 3,333 BCE to 2,675 BCE. So someone put together a normal-looking human body with something like 650 years worth of bones. And meanwhile, the research team wasn't able to get a carbon date from the skull, but they were able to extract some DNA from it. And by analyzing that DNA, they revealed that the skull belonged to a Gallo-Roman woman who is genetically related to remains at another archaeological site about 150 kilometers away. And because those remains did have a carbon date attached to them, the team could estimate how long ago this woman lived. At most, she and her genetic cousins were 28 generations apart. So roughly speaking, that's 784 years. So there's still some uncertainty here, but it means that the skull sitting on top of this otherwise Neolithic skeleton was at least 2,500 years younger than the rest of the skeleton. Meanwhile, DNA analysis also confirmed that the other bones came from at least 5 different people who weren't close relatives of each other. But based on how the bones match up physically, or rather don't match up, the researchers think that the remains of at least 7 people came together in this one skeleton. And in case that wasn't weird enough for you, there are also 3 badger bones found in that grave too. Each comes from a different badger and each separated by thousands of years. So now archaeologists have to figure out who did this, when, and why. First, they have to consider the possibility that this puzzle all stems from an archaeologist's error. Did someone on the original team mix up the remains after they were excavated? The team behind this 2024 paper thinks that's pretty unlikely since the skull was genetically related to other graves in the area. So if we don't have to worry about that, was this composite skeleton created by the Gallo-Romans from much older bones? It's possible, but if it's true, it'd be the first of its kind. And then why didn't the Gallo-Romans lay the skeleton out like they would the rest of their bodies? Why the even more vintage fetal position? So the more likely scenario is that the composite skeleton was created during Neolithic times and then disturbed by the Gallo-Romans millennia later. Archaeologists do have a few other examples of ancient composite skeletons, although they're not as old as this one and usually only feature a few different people's remains, not 7. Still, they can draw comparisons and speculate as to the why of it all. I mean, sure, this could be someone's idea of a prank for future archaeologists to stumble upon. We can't completely rule that out. But a more, perhaps realistic hypothesis is that they crafted a single skeleton out of otherwise unrelated bones to serve as a symbol of unity. Maybe Neolithic Belgians were really into found families. Whatever the why, the ancient people who created this composite had a detailed knowledge of human anatomy. They put all the right bones in all the right places. Fast forward 2,500 years, the Gallo-Romans might have been burying their cremated remains and accidentally disturbed this much older grave. We know the Romans had a reverence and respect for human remains, so perhaps they noticed the skull was missing and replaced it with one of their own to complete the body before reburying it. This could have been their way of making reparations for the disturbance. While there's still some guesswork involved here, it's clear that this skeleton tells a complex tale that spans many generations and cultures.
That graveyard might have benefited from a bit more security. Maybe a more intimidating tomb would have kept people from wandering in and creating their own skeletons from found bones. But constructing something like that would have been quite a trade-off. Like, where would you even find the space for such a structure? After all, it was a long-standing mystery why the pyramids of Egypt were located where they were. Here's how archaeologists solved that.
So to start off, the Giza Pyramid Complex is actually way more than just the Great Pyramid. There are also 2 other main pyramids, plus the Sphinx, plus several smaller pyramids and temples. The whole complex was built about 7 kilometers west of the Nile and about 10 kilometers from Mennefer, the capital of Egypt at that time. So pretty much out of the way when you don't have a dune buggy to get around on. And the tools and materials used to build the pyramids came from all over, including copper from the Sinai Peninsula, timber from Lebanon, and granite for the exterior from the city of Aswan, up the river. Papyri from the Sinai Peninsula tell us that Egyptians used barges to transport these heavy building materials down the Nile, and then possibly created artificial waterways to get the supplies from the Nile to the pyramid site. But that would still mean making over 7 kilometers of waterway. So the question remains why they picked that exact site in the first place. Like, instead of building canals leading to an artificial lake, it would have been a lot easier to just pick somewhere closer to the Nile. Well, it turns out that they were a lot closer to running water than we thought. Using radar satellites, researchers have been able to get a picture of what was under the surface of the desert. And they were able to see these tiny little depressions which were covered up by nearby farmland, which is why they'd been so hard to spot before. When the researchers took samples of the earth from more than a dozen meters below the surface, they found sand at the bottom. And yeah, that doesn't sound like a very big deal. Like, of course there's sand, it's a desert. But sand is normally only the top layer of a desert environment. And so when you find it lower down, that usually indicates that there used to be running water there. Putting together the channels they saw on the satellite imagery with the discovery of sand beneath the surface led the researchers to conclude that thousands of years ago, a branch of the Nile flowed through the area, parallel to the main river, but several kilometers to the west. They're calling this now dried up branch the Ahramat branch, which is Arabic for pyramid branch, which is pretty fitting since aside from Giza, there are 31 pyramids located along the 64-kilometer stretch of the former river that they were able to track. The pyramids on the Ahramat branch were built over the 1,000-year period between 2600 and 1600 BCE, suggesting that this was a significant Egyptian waterway for quite a while. But now, just a few thousand years later, there's barely a trace of the Ahramat branch left. So what happened to it? It's likely that the disappearance of the Ahramat is related to larger changes in the Nile River Valley over the last 14,000 years. Back then, the Eastern Sahara Desert was a lot wetter than it is today, thanks to stuff like glacial melt and sea level rise. There were large river systems and lakes, and the amount of rainfall actually made it a savanna or grassland instead of a desert. It's even known as the African humid period. At that time, there was so much water that the Nile River Valley was a soupy, swampy mess that meant it was pretty much inhospitable, which meant that there was enough water that the Nile River would have easily formed other branches, and nobody could actually live anywhere near the actual rivers because there was too much swamp in the way. Somewhere between 6,000 and 10,000 years ago, things started to dry out enough to allow people to live a little closer to the riverbanks. And then about 5,000 years ago, things shifted even more dramatically. Less rainfall allowed the sediment to build up in the Nile floodplain, which meant there was a whole bunch of dry farmland above the marshes. And the new dryness of the Sahara pushed settlements even closer toward the Nile, where there was still water. But things were still wetter than they are now, allowing for those branches of the Nile to keep thriving. Branches like the Ahramat. When and where settlements were built tells us what was happening with the location and water level of the Ahramat over time. And tracking those settlements showed that the river started to dry up, but also slowly shifted more towards the east. This change was likely due to a few factors, including a shift in tectonic plates that tilted the ground, so the Ahramat was basically uphill from the main stretch of the Nile, and then that tilt combined with windblown sand and sediment building up along the river caused the Ahramat to finally run dry. And just like that, the river was hidden for millennia. Uncovering the Ahramat is the first step in discovering more hidden aspects of ancient Egypt. Because we know that people like to build settlements along rivers, researchers think that following the branch's path will allow archaeologists to discover new historical sites and better preserve them. It also provides new information on the cultural development and interconnectivity and the trade routes of ancient Egypt, because it means that many cities and towns were directly connected by river, not just over land. Which just goes to show that even after thousands of years, there's still so much more to learn about the pyramids.
While we're talking about the pyramids, we have to talk about ancient Egyptian embalming practices. For a long time, we didn't know how mummies were made. But when scientists solved that mystery, they got the added bonus of learning what 5,000-year-old perfume smells like too. If you want that smell profile, just keep watching.
The ancient Egyptians had what archaeologists call a sophisticated funerary culture. It's less that they were obsessed with death, and more that they thought life was pretty awesome and expected more of the same in the hereafter. They wrote down a lot of what they did to make sure that would happen, but not all of it. We know they used complex mixtures to embalm bodies and organs, but not what those mixtures were made of. What materials did they choose and why? Where did they get them? And what does that tell us about the lives of those people so long ago? Fortunately, we have access to tons of this stuff in the archaeological record. The canopic jars used to preserve mummified organs, sarcophagi, and even mummies themselves all contain traces of embalming material. Let's consider the mystery of Ka and Merritt. These were a husband and wife buried together sometime after 1400 BCE. Ka was an architect who served under 3 different pharaohs and seems to have been held in high regard, which makes it weird that the mummification of these bodies seems sloppy. Merritt's skeleton is in awful shape, and neither of them had their organs removed. Usually what we see in mummification, at least for royal mummies, is that the heart will be preserved and put back in the body, certain organs will be embalmed and preserved in canopic jars, and the brain will be tossed out because who needs that? But none of this was done with Ka and Merritt, leading some to propose that they were never mummified at all, just wrapped in linen. However, in a 2015 study, researchers challenged that view with perfume, or more specifically, with chemical analysis of the embalming agents present in Ka and Merritt's mummies. The technique they used is called gas chromatography mass spectrometry, or GCMS, and this is a real favorite among chemists. It's a form of chromatography, a fancy word for separating out a mixture of chemicals. If you've ever done that experiment as a kid where you make a mark on a piece of paper and watch as water separates the components of the ink, you've done chromatography. Congratulations. By forcing the components of a mixture to travel at different speeds, you separate them so you can identify them one at a time. In GCMS, the sample is vaporized and sent through a long, skinny tunnel to separate the components. Each molecule is then broken up into fragments, each of which has a distinct size and charge. You can fit these together like a molecular puzzle to identify what molecule they started out as. In doing this, they found that Ka's mummy contained an embalming agent consisting of a base of oil or fat, aromatic plant extract, conifer resin, and additional plant-based substances. Hey, they were analyzing 3,500-year-old mixtures here. It's usually not going to be possible to ID every ingredient down to the plant species, but you can at least get a rough idea. Merritt's recipe was similar, but also contained beeswax and, bizarrely enough, fish oil. Not exactly what I want in my fragrances, but okay. Her outer shroud also contained pistacia resin. That's a group of trees with several uses in fragrance, including mastic and terebinth. From this, the authors of the paper argued that Ka and Merritt's preparation for the afterlife wasn't shoddy at all. These were fancy imported perfumes, and the state of their mummies, all things considered, wasn't that bad. In fact, the researchers proposed that the presence of coniferous resins went a long way in preserving their bodies, thanks to the anti-decay chemicals found in pine trees. Sure, they didn't get the full pharaoh treatment, but who does? Besides pharaohs. Then there's Senetne, a woman who lived around 1450 BCE, not long before Ka and Merritt, and was a wet nurse to King Tut's great-great-granddad. In a 2023 analysis of her canopic jars, researchers noticed something that shouldn't have been there. The team used GCMS to identify the substances present, but they also used liquid chromatography tandem mass spectrometry, or LC-MS-MS. This is a type of chromatography done in liquid rather than gas form, but as the name suggests, you sort of double identify the stuff after it's pulled apart. You once again fragment the molecules into pieces with a certain mass and charge, but then you fragment the fragments. This gives a better and more specific signature because all those little puzzle pieces can only fit together in certain ways. Senetne's mummification residues included beeswax, various oily substances, and resin from pine trees, which might have been larch or cedar. They also contained the chemical signature of something that might have been a fancy ingredient called damar. And by fancy, I mean trees that produce damar grow in Southeast Asia. We know that Egyptians used damar much later on, by around 600 BCE, but this finding would push back our knowledge of Egyptian trade links with Southeast Asia by a good 1,000 years. We really don't have any archaeological evidence for that kind of trade, though, and the stuff they identified as damar could have also been pistacia again. So they're not rewriting the history books just yet. A museum in Denmark is actually using a recreated version of Senetne's perfume as part of an exhibit. So if you want to know what immortality smells like, start researching flights to Copenhagen. Finally, we need to talk about Nesta-Wedjat. She died and was interred around 700 BCE near the city of Thebes. In the 19th century, she and her 3 coffins were looted and eventually ended up at the British Museum. During her stay at the museum, it was incorrectly determined that Nesta-Wedjat's mummy didn't belong with the coffins and they were separated. This effectively erased erased her identity, which according to ancient Egyptian belief was an important part of her survival in the afterlife. In a study published in 2021, researchers used various chemical techniques to study Nesta Wedjat's mummy as well as the 3 coffins they suspected might rightfully belong to her. And they suspected this partly because, well, they'd come in together, plus there was a stain on the mummy's shoulder that matched the innermost coffin. Their techniques included, once again, GCMS, but also one called Fourier Transform Infrared Spectroscopy, or FTIR spectroscopy. This is a different strategy than chromatography. Rather than separating the sample, you look at the infrared light it absorbs. Then you do some math based on the light that isn't absorbed to get an ID. The perfumes from the mummy and the coffins were a match. The embalming material was made of beeswax and an oil or fat. Pine-type trees show up here again too, with signatures that can be interpreted as juniper, cypress, and or cedar. The researchers repeated the claim that the pine-based substances had a preservative effect due to the presence of compounds called sesquiterpenoids. These compounds smell nice, which is obviously a good enough reason to put them in perfumes and balms, but they're also shown to resist decay, and given their widespread use, it's definitely possible that Egyptian embalmers knew that. In the end, the results clearly showed that Nesta Wedjat and her coffins belonged together. Her name and identity have been restored, and thus a part of her immortality. So now we know. As you're making that journey through the underworld, you're accompanied by the scent of pine trees, rare imported ingredients that reflect the care your people took to make sure you had a nice afterlife. There's really no match in history for the technology the ancient Egyptians developed around mummification. But the technology we have to unravel it and reveal the stories of these 4 people is pretty darn neat too.
It's probably no surprise that there were chemicals involved in mummification, but where did ancient Egyptians get those resources? Researchers have read tons of documents pointing to a place called Punt. But where that place is was a mystery, until archaeologists solved it with the help of some unlikely primate research assistants. Here's how baboons led them to the lost civilization of Punt.
Now, Punt didn't literally drop off the map Atlantis style, lost to the ages due to an angry god. Instead, cultural and linguistic changes seem to have gradually left it behind. We don't even know its real name. Hieroglyphs don't really have vowels, so the exact pronunciation of Punt is a medium-sized question mark. You could argue for something like Puenet or even Puenenet, but whatever it was called, it was a source of fabulous and expensive stuff. Incense was an especially big deal to the Egyptians, but they imported plenty of ebony and animals too. And this wasn't just a 1 or 2 time splurge. Punt is mentioned in hieroglyphic texts that span millennia. Consider the Old Kingdom ruler Sahure, who way back in the 25th century BCE commissioned a series of carvings that depict an expedition to Punt returning with animals and other cargo. Or there's the Middle Kingdom text, The Tale of the Shipwrecked Sailor. It's about 500 years younger than those carvings, but that still makes it about 4,000 years old. It sometimes gets called the first work of fiction known to history, and in this tale, unsurprisingly, a sailor is shipwrecked. We can cut them a little slack on the title because they were just getting started. But anyway, in the tale, our shipwrecked sailor guy meets a giant golden serpent that describes itself as the ruler of Punt. It also showers him with a bunch of gifts before the dude gets home safe and sound. Now, this is clearly a made-up tale. The writer probably didn't think the actual ruler of Punt was a golden snake, but it shows that at the time it was written down, the land of Punt was likely associated with incredible wealth and a mystical, otherworldly vibe. But perhaps the most famous representation of Punt is a set of reliefs on the walls of a temple dedicated to the pharaoh Hatshepsut. Hatshepsut reigned in the 1400s BCE, and she was clearly very proud of the expeditions she dispatched. The reliefs depict both a bunch of Puntish goods being presented to her and Punt itself as a place filled with palm trees and raised buildings you have to access via ladders. And this super fancy relief also suggests that contact with Punt had been lost until Hatshepsut came along to reestablish it. And finally, we've got an inscription on a stone slab that dates back to like 500 or 600 BCE that suggests trade with Punt may have carried on for another 1,000 years after Hatshepsut's expedition. Put all of this together, and Egypt's relationship with Punt appears to be so important for so long that some scholars recognize it as the beginning of global commerce, period. Of course, to confidently apply the global descriptor, it would be nice to know exactly where Punt was, and we've been asking that question since the 19th century. We know it was to the south southeast of Egypt, but that doesn't narrow it down a ton. We also know that ancient Egyptians weren't history's greatest boat builders, and their boats didn't have the deep keels that make it easier to navigate an ocean. So for a long time it was thought that the route to Punt had to go overland or up the Nile River. Until 2005, that is, when archaeologists were excavating an ancient seaport and stumbled upon an inscription that dates back to the 19th century BCE and basically says, "Pharaoh told me to launch an expedition to Punt from here." So that kind of settles that they would have sailed to Punt, but you might have figured out that still doesn't tell us where Punt itself is. Back in the 19th century, scholars initially settled on Somalia, but since then it's been shifted around to the Arabian Peninsula, southern Sudan, or northern Ethiopia, and even places as far away as Uganda or Mozambique. And these days, the consensus seems to be drifting slowly towards present-day Eritrea. But without archaeological evidence, it's pretty hard to narrow it down much more than that. But that hasn't stopped scientists from trying, and they've turned to a rather peculiar version of a first-hand account. Because, you see, the secret of Punt may lie with the mummified remains of baboons. The ancient Egyptians considered baboons to be kind of a big deal, and Thoth, a god of knowledge and writing, was sometimes depicted as a sitting baboon. And baboons were venerated, sometimes even mummified, for millennia. From prehistory straight up to the last dynasty of pharaohs who ruled from around 300 to 30 BCE. There is one catch though. Baboons aren't native to Egypt, and they never have been, or at least never at the same time as humans. Every single baboon we found there, and we found a lot, was either imported or bred in captivity. So where did ancient Egyptians get them? From Punt, of course, or at least some of them anyway. Both Sahure's carvings and Hatshepsut's temple specifically depict baboons, and the tale of the shipwrecked sailor includes them among the gifts. So simple reasoning suggests that if we can figure out where the baboons are from, and we already know they're from Punt, that lets us finally pinpoint Punt on a map. Now, you can't ask a 3,500-year-old mummified baboon where it was born. Not only do they not speak any human languages, they're dead. But believe it or not, there are a few ways scientists can figure out an animal's geographic origin. And one of those is with the element strontium, or more specifically, 2 isotopes of strontium. Every atom of strontium has the exact same number of protons. That's what makes them strontium in the first place. But atoms of the same element are allowed to have different numbers of neutrons. Some neutron counts make an atom unstable and radioactive. Some are perfectly stable, but they're all just different isotopes. It takes a bit of effort, but scientists can detect the differences between isotopes of the same element, which opens up a whole flood of applications. See, if you wander out into nature and pick up a rock with any strontium in it, you're almost certainly going to find a blend of at least 2 isotopic flavors, called strontium-86 and strontium-87, and the exact ratio of that blend will vary depending on where the rock comes from. But strontium isn't just found in rocks. It naturally gets taken up by the body in trace amounts, and incorporated into bones and teeth. But teeth are done growing after a bit, like 3 years into a baboon's life, while bones continue to remodel themselves. So studying the strontium ratio in a baboon's teeth can tell you where it lived when it was young, if not where it was born, and the ratio in its bones can tell you if they eventually moved away for a significant period of time. To find where a specific animal came from, you just have to make a map detailing the strontium isotope ratios in different locations, test the ratio of strontium in your animal, and then match that ratio to the right spot on your map. And in a 2020 paper, researchers did just that with some ancient Egyptian baboons. Some of the specimens matched up with strontium ratios you'd naturally find in, well, Egypt. While that's not particularly helpful in finding Punt, it does support the idea that baboons were sometimes raised in captivity. However, the authors did find one baboon skull dating to the New Kingdom that had clearly been imported from somewhere else. The strontium ratio in its bone tissue matched with Egypt, suggesting it had lived there for some time. However, its teeth had a totally different ratio, which means it had been born outside of Egypt. The question then became where it had been imported from. The strontium ratios in the teeth pointed to somewhere in Yemen, Eritrea, Djibouti, Somalia, or Ethiopia, which doesn't get us much of anywhere in narrowing down Punt's location. At the very least, it did match archaeological consensus. But fortunately, we can do better. Maybe even a lot better. See, it's possible that a 2023 paper by a mostly different group of researchers has narrowed Punt down to an exact site. But to explain how, I have to go into just a little bit more history. By the time ancient Egyptians had entered their let's get taken over by Alexander the Great phase, circa 300 BCE, they were getting their baboons from a place called Adulis. And we happen to know exactly where Adulis was, on the coast of present-day Eritrea. So these researchers weren't looking for Punt, they were looking to establish exactly how far back trade between Egypt and Adulis went. And they were especially interested in a cache of baboon remains dating to somewhere around 800 to 500 BCE. But instead of strontium, they went straight to DNA evidence. The researchers sequenced the mitochondrial DNA of a bunch of baboons from this cache, and also referenced sequences that had already been published elsewhere. Altogether, they ended up with 14 skeletons and 1 mummy to work from. Now, previous work had already created a way to assign a baboon to a specific mitochondrial DNA family that corresponds to a specific geographic region. So the team was able to show that their mummified baboon corresponded to a genetic group that, at least today, lives in Eritrea and eastern Sudan. If they haven't moved around much since then, and science suggests they have not, this closely connects the mummy to Adulis, which for an archaeology nerd is really interesting, because this potentially pushes back the date that ancient Egypt was trading with Adulis by centuries. However, it also draws an even more tantalizing connection back to Punt. Remember that fragmentary inscription I mentioned, the one that talks about Punt around 500 or 600 BCE? Well, the age of that inscription overlaps with the age of this cache of baboons. So if the baboons are from Adulis, but maybe also from Punt, then maybe Adulis is Punt? Maybe it just went through a little bit of a rebrand. Or as the paper puts it, our findings appear to establish primatological continuity between Punt and Adulis. It's certainly not a slam dunk, and the authors don't try to pretend like it is. But apparently they're not the only researchers making this connection, and they're making it with DNA evidence. So have we found the lost land of Punt? Well, it seems very possible, though I suspect archaeologists will continue to speculate for years to come. It's kind of funny when you think about it. The ancient Egyptians venerated the god of knowledge through these baboons and preserved their bodies as part of that. And that act of veneration kept the baboons around long enough that we're able to learn from them today.
By now, we've covered the ancient lives of people around the world. So to end this giant compilation of archaeological discoveries, here's 3 final civilizations and how they fell.
The Acadian Empire once stretched across modern-day Syria and Iraq. It was the first ancient empire of Mesopotamia, and it lasted for nearly 200 years. But sometime around 2150 BCE, it collapsed. The reason for this collapse was mostly unknown until researchers in the 1970s began studying an archaeological site called Tel Leilan. This site is located in northern Syria and used to be under the control of the Acadian Empire. The Tel Leilan site holds the ancient remains of a city that was inhabited between 2700 to 2200 BCE, then uninhabited for about 300 years, and then inhabited again beginning around 1900 BCE. And since those 300 years where the city was deserted coincide with the collapse of the Acadian Empire, it piqued a lot of people's interest. When researchers dug into the soil around the city, they found a 20-centimeter deep layer of gray, sand-like pellets, bracketed by layers of thick, loamy soil. They dated that layer of sand to 2200 BCE, around the time the settlement became abandoned. This was confirmed when another study looked at deep sea cores from the nearby Gulf of Oman. The sediment that makes up deep sea cores originally comes from land, and ends up in the ocean either by floating along rivers or landing on the surface as wind-blown dust. Since sediment builds up really slowly in the ocean, deep-sea cores can act as a physical timeline that lets us study huge time periods. And the cores from the Gulf of Oman showed an abrupt increase in land-based dust from around that time, which was likely from the Acadian Empire. Wind-blown dust tends to increase when areas dry out, leading scientists to suspect that a severe drought took down the empire. Really puts new meaning into the phrase, dust in the wind, huh? While drought is a common cause of collapse of many ancient civilizations, sometimes the problem isn't the drought itself, but what happens afterwards. That's likely what caused the collapse of Angkor, the ancient capital of the Khmer Empire located in what is now Cambodia. In its prime, Angkor was an archaeological wonder, with a population of nearly 1 million people and a land area roughly the size of Los Angeles. You can still visit the city's temple complex, Angkor Wat, today, and the city itself is an active archaeological site. Unfortunately, the city collapsed in 1431, which historians thought was due to an invasion by outsiders. But the real story may have been buried underground for centuries, hiding in ancient pollen. Researchers looked at drill cores taken from 2 meters below the Earth's surface at Angkor Wat, and they were able to look at preserved pollen grains, which let them reconstruct how the environment of the city had changed across centuries. See, looking at the pollen tells you what kind of plants were growing in the area, and that'll change based on whether an area is being actively farmed or whether nature is taking its course. These pollen grains suggested that the collapse of the city didn't happen all at once, so an invasion no longer made sense. It looked more like the civilization gradually collapsed over time. And there was even more evidence of this slow decline hiding in tree rings from trees that were alive during Angkor's collapse. Trees grow rings every year. During dry years, trees grow more slowly, so the rings tend to be narrow. And during wet years, the tree grows faster, so the rings tend to be wider. The Angkor tree ring showed evidence of a long, multi-year drought in the middle of the 14th century. But it wasn't the drought alone that brought about the city's collapse. After the drought, changes in the strength of the seasonal monsoons resulted in a lot of rain. This region of the world is already pretty rainy, so we're talking about huge amounts of rain, enough to cause major floods. To make matters worse, the floods were followed by more drought. Angkor had a pretty robust water capture system, but researchers believe that the shifts between drought and flood conditions may have overwhelmed it, making people desert the city for a more stable climate. Another civilization likely collapsed during the 14th century, although it's hard to tell exactly when they vanished, because they were located so remotely that no one could contact them for centuries. These were the Greenland Norse, a group of Vikings that settled in Greenland sometime around 1000 CE. The settlements were thriving for centuries before they lost contact with the rest of the world. In 1721, after more than 200 years of not hearing from the Greenland settlers, missionaries tried to re-establish contact with them, only to find crumbling villages and ruins. Theories about this collapse included everything from Black Death to piracy. But today, researchers think the collapse was caused by climate change. See, researchers were able to reconstruct the climate of Greenland from the oxygen isotopes found in Greenland lake sediments. The 2 most common isotopes of oxygen are O18 and O16, which is much more common in nature than its sibling. Because O18 is heavier than O16, it requires more energy to evaporate and circulate within the water cycle. So it moves through the cycle more in warmer, high-energy periods of time. And during warmer periods, there's more O18 in the rainfall. And that means that if we look at the ratio of oxygen isotopes present in things that were around in a given time period, we get an indication of what the temperature was at the time. But how do we check up on those old isotopes? Simple. Bugs. See, insect larvae get most of their water from rainwater, so the O18 in their bodies roughly correlates to the O18 of the rainwater during their lifetimes. Researchers were able to calculate the oxygen isotope ratio from fossilized insects, giving them a proxy for the temperature at the time the bugs had lived. This reconstruction showed that between 900 and 1400 CE, roughly when the Norse settled Greenland, Greenland was 1.5 degrees Celsius warmer than normal. The warmth would have made Greenland look like a great place to settle and build a civilization, luring the Norse in. But it was a trap, because after 1400 CE, temperatures got a lot colder. Now, this cool down isn't isolated to Greenland. It happened all over the northern hemisphere and is known as the Little Ice Age. During the Little Ice Age, the northern hemisphere got about 0.6 degrees Celsius colder, and Greenland was hit by the cold particularly bad. The average temperature dropped by 1.5 degrees Celsius and stayed there for about 400 years. Unfortunately, the Greenland Norse weren't really equipped to deal with that kind of cold. Although evidence showed they did their best, they ultimately weren't resilient enough to handle the changing climate. None of us were around to witness the collapse of these three civilizations, which means that figuring out what happened to them isn't exactly straightforward. To fill in these knowledge gaps, scientists have to become detectives, looking through the clues left behind to figure out what happened to people hundreds to thousands of years ago. From deep sea dust to ancient trees to fossilized bugs, chemical and biological clues can tell us so much about the people of the past. And sometimes, those clues can even tell us about the forces that brought down empires.
So if you've never heard of those civilizations, now you know why. There's a huge amount of information that archaeologists have unearthed over the years. Through those investigations, they've solved countless mysteries. But the coolest part is how many mysteries they still get to hunt down. The world will never stop being full of wonder. Thanks for staying full of wonder yourself and for watching this SciShow video.